Hello everybody. I want today to present the work we did with colleagues involved in the CENSE project, which tries to evaluate the sound environment with an automatic characterization of the sound sources, such as traffic, voices and birds. The aim of the work package dedicated to the perceptual analysis is to produce sound quality maps instead of sound level maps, starting from acoustic measurements collected with a network which is composed of more than 100 sensors in Lorient. The workflow of this study started with installation of the sensors. In parallel, we sent questionnaires to propose perceptual models for sound quality and annoyance. The models showed that the presence of sources has a large influence on sound quality, so we tried to evaluate the presence of these sources automatically on the sensors. And then we proposed maps to represent sound qualities such as pleasantness or annoyance. We sent 2,000 questionnaires and we received 300 answers. In this figure, the red areas are the location of the respondents, and the small dots correspond to the sensor locations. So the questionnaires started with classical soundscape scales, such as pleasantness, evenfulness, etc. But here in this presentation, we will look at the pleasantness. We asked for characterization of different sources, such as traffic, road, train, and air, because of the military bases in Lorient. And we differentiated calm voices and expressive voices, which could have different impact on sound quality. Then we asked for indoor and outdoor annoyance, again, sources characterization, and housing data. Do people have double glass windows? Do they have quiet room in their housing? And finally, we ask for personal data. In our corpus, age and noise sensitivity are decorrelated. So the analysis led to perceptual models, but here I have presented results from Cartographic and Graphic project that have been carried out in Paris some years ago, and where people were asked to answer the questionnaire in the street to evaluate the sound quality. You see that the overall loudness has a negative impact on pleasantness as well as the road traffic noise. On the contrary, birds have positive impact. In the CENSE project, participants were not questioned in the street, but we see that the same kind of regression with negative impact of loudness and negative impact of traffic with air traffic. We can notice that the expressive voices have a negative impact compared to the Parisian study. But in Paris, we didn't separate the two kinds of voices, so it is important to do that. For indoor annoyance, we see for open windows that both expressive and calm voices appear in the regression for opened windows, but with opposite signs. The expressive voices increase the annoyance, whereas calm voice decrease the feeling of annoyance. For closed windows only, expressive voices have a significant influence on annoyance. If we add personal data for housing, we see that explained variance of the models increase, showing that annoyance is also impacted by what we call non-acoustic factors. The presence of quiet room in the housing reduces the perceived annoyance. As we saw that sources appeared in the perceptual models, we tried to automatically calculate the percentage of source presence from the third octave band acoustic measurements. First, we created with the SimScene software about 100 sound scenes composed of several controlled channels. Each channel corresponds to one type of source. Then, for each second, we try to recognize what are the emergent sources. For example, for the car, we calculate in each third octave band the emergence of the sound level of the source, the car here, compared to the global sound level of all the other sources. If the mean value of the emergence is above a certain threshold, then the source is identified in the 1 second excerpt. This identification is carried out all along the duration of the scene, and we can calculate the percentage of presence of each source channel. If you want more details, you can have a look on this paper. In order to validate this indicator, we did a listening test, asking participants to rate the time percentage of each source. The correlation in the green part of the table are very good, above 80%, better than the correlations issued from other indicators found in the literature in the yellow part. With the confidence in our indicators to automatically annotate the sound scenes, we trained a neural network with about 500 sound scenes. The final model made it possible to calculate the percentage of time of presence for each type of source on any duration of the sensor measurements. As an example, on the top figure, you see there the percentage of cars during each first 10 minutes of each hour, extracted from one sensor along a thoroughfare. We recognize the rhythm of the day with a reduction of the traffic at night and with more traffic during night weekends compared to the nights of the weekdays. We see also on the bottom figure that birds are more present in the morning simply because they sing at the sunrise. And to finish the workflow, we can now represent the sound quality through perceptual maps. The portal has been created for that. Unfortunately, as we had less functional sensors as we expected, and more than 300 questionnaires, we decided to interpolate the questionnaires between respondent locations instead of sensors. We can show then the pleasantness of the city. But it is also possible to show the different types of sources. We can see that birds are present along the river with the seagulls. We see also the expressive voices which are present in the city centers with bars and in the festival park. Unfortunately, with the sanitary crisis, we couldn't cross questionnaires with measurements to validate our workflow, except during the lockdown, where we asked participants to fill again a questionnaire. This will be presented in EURONOISE conference by Pierre Aumont. We should now calculate the sound pleasantness with the source indicators collected with the sensors, for example, every 10 minutes, to produce dynamic maps in real time. But this has to be done. Still, thank you for your attention.